In this video, I'm going to go over the review for the quadratics test. Remember, the review is only 10 questions. Each question is representing a test question. If at any point you need to pause or rewatch, please do so. On this first question, we are asked to find the maximum height. Here, it tells us that Jessica is dropping from a height of 42 feet. So if she's dropping, it's going to go straight down, which means our maximum height is that 42. Now, the other way we could go about this is using our equation for axis of symmetry, because that will give us the x value of the vertex. If we know the x value of the vertex, we can go through and find the y value. So I'm going to go ahead and show you the other method. So using this other method, the equation for the axis of symmetry, I went ahead and I wrote out. We have here is x equals negative b over 2a. I've also identified the a value, which is negative 16. Since we don't have just a t and a coefficient, our b value is 0, and then our z value is negative 42. So when I substitute my values in, I get x equals negative my b value of 0 divided by 2 times my a value of negative 16. And when you simplify, we get x has a value of 0. So remember, this is the x value of the vertex. Then we got to go find the y value, and we do this by substituting the 0 into our original. So h of 0 equals negative 16 times 0 squared plus 42. And anything times 0 is 0, so h of 0 equals 42, making our y value 42. When you bubble this in, because you will have a griddable on your test, you'll do 4, 2, and make sure you completely fill in the circle that goes with the 4 and the circle that goes with the 2. Question 2, we're asked to identify 3 things. We need our axis of symmetry, the vertex, and then after that, we want to be able to determine the range value. The first thing to find our axis of symmetry, remember it's x equals negative b over 2a, and you will be able to use the formula chart. Looking at the equation, I have an a value of 1, because we could say there's a 1 in front of the x squared, a b value of negative 8, because that's what's in front of the x, and a c value of 15. So when I come to my axis of symmetry, x equals negative my b value of negative 8 divided by 2 times my a value of 1. This minus our negative turns into a positive. So we have positive 8 divided by 2, because 2 times 1 is 2. So this gives us our axis of symmetry is x equals 4. You must include that x equals. To find the vertex, we need to substitute our x value into the x's of our equation. So I have, and that will solve for y. So my y is going to equal my x value of 4 squared minus 8 times my x value of 4 plus 15. So y equals 4 times 4 is 16. Negative 8 times 4 is 32 plus 15. 16 minus 32 is negative 16. Negative 16 plus 15 comes out to a negative 1. Our final step is going to be to write the vertex as an ordered pair. So in parentheses, I'm going to have my x value from the axis of symmetry, comma, the y value that we just solved for. The last part is asking us to determine the range. Remember, the range is referring to all the y values. So I want y. I'm going to take the y value from my vertex. And then I'm going to look at my a. Because my a is positive, that means the graph opens upwards. So I'm going to want all the y values greater than or equal to negative 1 for my range. So on this problem, we want to go ahead and start off with the problem they're giving us and using that to find the axis of symmetry. Once we find our axis of symmetry, we can use that x value to go ahead and identify what the vertex is going to be. For the axis of symmetry, you want to label your a value. So right now I have an a value of 1, a b value of negative 2, and a c value of negative 3. The formula for the axis of symmetry, which is provided on your formula chart, is x equals negative b over 2a. So x equals negative, my b value, which is a negative 2, divided by 2 times my a value, which is a 1. Once again, two negatives create a positive. So we have positive 2 over 2, because 2 times 1 is 2, which makes my axis of symmetry have a value of a positive 1. So positive 1, we have B. A is not good. C works, and D works. Now, before I go any further, I do want to go ahead and eliminate answer choice C because the graph is opening down, but I have a positive A value. Our next step is to determine what the vertex is so we can determine if the answer is B or if the answer is D. So in the vertex, we come back to the original problem, and we're going to input this 1 in place of x. So I have f of 1 equals 1 squared minus 2 times 1 minus 3. So 1 squared is 1. Negative 2 times 1 is negative 2 minus 3. Combine, 1 minus 2 is negative 1. Negative 1 minus 3 is a negative 4. So this means we have a vertex of my x value of 1, and then when we plug that in, we got a negative 4. So between B and D, I'm looking to see which one has a negative 4. See, it's not B. Here, it is at negative 4. So my answer is D, because my vertex is 1, negative 4, and my axis of symmetry is x equals 1, which matches the equation. This is one you could have just gone, type this into your calculator and gotten the match the graph instead of doing the work. Question 4, we're asking to identify the solutions of the quadratic. So we're solving for x. If you minus your 108 from both sides, This is going to leave you with x squared minus 121, and that's it, equal to 0. Another way you could write this is x squared plus 0x, because there's no b value, minus 121 equals 0. And this is where you would go ahead and do your factoring. What are the multiples of 121 to where when you add them you get 0? And that's going to be negative 11 and positive 11. Because this is an x squared, we can go straight to our shortcut. And we can say x minus 11 and x plus 11. Because it's equal to 0, we got to take it one more step and say x minus 11 equals 0 and x plus 11 equals 0, which means we have an x value of 11 and an x value of negative 11. So you could write this as 2 points, 11, 0, and negative 11, 0 in parentheses, or you could use the braces to indicate a set of negative 11 and positive 11. So here on question 5 and 6, we're looking at the bolded graph and how it's been transformed from the parent function of y equals x squared. You have a little box here to kind of help out with what it is that we're looking for. So the first two is targeting the width. And here, if you're having difficulty, from the vertex is going out 1 and up 1, and this vertex is going out 2 and down 1. So it's becoming wider. The next is talking about whether it was translated up or down. And you're talking about the vertex. So from the vertex, it's gone down 1 unit. Then we have the next two, we're talking about if it's translating to the left or to the right. And here from the vertex, it's going to the right 4 units. And then it's talking about the reflection. So the reflection is, because it's opening down, anytime you have a parabola that opens down, it's a reflection. Then on number 5, it's talking about the domain and range. Domain is going to be those x values. And for our purposes, when there's not a verbal situation attached to a parabola, the domain, because we have an arrow on the left and on the right, that's indicating all real numbers. And then we have the range. The range are those y values. Now this parabola, the y value, the highest y value is a negative 1, and that's also the y coordinate to the vertex. From here, it's going down. So the range is going to be y is less than or equal to negative 1. Question number 7, you're asked to describe the transformations from the parent function given equation in vertex form. So when you're looking at this, the first thing is going to be to look at the number out front. Is it positive or is it negative? This one's positive, which means no reflection occurred. Then I see it's 1/3. So 1/3 means it's becoming wider. Remember, I compared this to the slope of a linear function, up 1/3, up 1/3, as opposed to up 1/1. This graph from from the parent function compared to this one has become wider. Then we're also gonna go into what's inside the parentheses. Because it's a -2, remember in the parentheses we do the opposite. So this is gonna be to the right 2 units. And then we look at what's outside the parentheses is a -4. So that means it's going down 4 units. So on question number 8, we're going to write an equation in vertex form that's following these transformations. So I'm going to start off with f of x. Remember, whatever goes outside is determining if it's been reflected or if it becomes more narrow or wider. And here we see it's more narrow. So I need a number close to, or excuse me, I need a number greater than 1. I need a number greater than 1. It can be any number greater than 1. I'll just go with 7. But once again, any number you pick, as long as it's bigger than 1, it's going to make it more narrow. Then we have our parenthesis x. Inside, this h value is talking about if you're shifting to the left or to the right. Here we see we're shifting to the left. Left indicates a negative, but remember in parentheses we do the opposite, so that's going to be a plus 3.5. Close the parentheses, and then you put your exponent of 2. And then the last transformation is going down the 5 units. Since this is outside, we don't need to worry about making any adjustments. We can just go ahead and do a -5. On question number 9, when you get this test question on tomorrow's test, everything's already going to be in y = form. So you could technically just type both equations into the calculator to see which ones are equivalent. For those of you who want the algebraic method, what you would do is I would write both of these in standard form. So starting over with what's on the left, my a, this means we have y = negative x minus 6 times x minus 6 minus 4. This x squared means you have x minus 6 twice. When you multiply, we get x squared minus 6x minus 6x plus 36. That's still in parentheses. I still have my -4. Distributing the negative out front, that's going to leave us with a negative x squared plus 6x plus 6x minus 36 minus 4. And then we want to combine our 6x's if you haven't already, and combine the negative 36 and negative 4. So this leaves us y = negative x squared plus 12x minus 40. Looking at the second equation, once again, we would want to write this in standard form. So I'd minus the x squared from both sides first. This leaves me with negative 12x plus y plus 40 equals negative x squared. Then I'm going to add my 12x to both sides. This leaves me with y plus 40 equals negative x squared plus 12x. Then I'm going to minus my 40 from both sides. And that leaves me with my final answer of y = negative x squared plus 12x minus 40. And we can see these match, so they are equivalent. Once again, you did not need to do all of this arithmetic. You could have just gone ahead and typed this into your calculator. Negative, parentheses, x minus 6, close parentheses, squared, minus 4. And then on the second equation, you would have to get the y by itself. So you would have to, this is what you would end up typing in. The negative x squared plus 12x minus 40. Okay, the last problem here, number 10, is asking after how many seconds is the rocket going to hit the ground? This ground is the key word because that's referring to those rocks. The roots, the zeros, the x-intercepts, the solutions. So this is kind of going back to something from our last unit. You can factor, or you could type this in the calculator and see where the graph crosses or touches the x-axis. I'm going to go ahead and factor. So I'm going to take my negative 16 t squared, plus 48 t, and I want to know what is my GCF, because that's of this. So remember, if you have a negative, you want to take that out. 16 and 48 are both divisible by 16, and they both have that t, so I'm going to take that out. Then I put back the leftovers, which is a t. 48t divided by negative 16t is a negative 3. Because we're looking for those solutions, we set it equal to 0. So I have negative 16t equals 0, and I have t minus 3 equals 0. Anything divided by 0 is 0. So here I have one x-intercept at 0. And then my other one, if t minus 3 equals 0, that means my t has a value of positive 3. So I have another x-intercept at a positive 3. In the verbal situation, time starts at 0. So it starts at 0. The rocket is launched. It goes up and it comes back down. And when it comes back down and hits the ground, that is our 3 seconds. All right. Good luck.